Hello, everybody. This is Dr. Sherie Viencek, and I am going to present the first part of the Brain Health Seminar. We had some recording difficulties, so we're re-recording this. This is a three-part series with Linda Clark and Jean Halton and myself, and we have just gathered so much information about the brain health. We just wanted to share it with the community at large and just start a dialogue about this really interesting topic. So Linda had preceded me with a talk about neuroinflammation, and I'm going to continue on that. So the brain has a new discovery. So there is a lymphatic system that was discovered in 2014 by a Danish scientist, and they found out that this system is a combination of the glial and the microglial and astrocytes and perivascular network, and that it runs parallel to the arteries and uses the pushing of blood in circulation to keep it moving. So this is very important because this speaks to our own vascular health, our own movement, our own circulation, and also is a way of looking, a new way of looking at vascular dementia, that it has to do with this lymphatic system. So why is this important? It's important because it gets rid of metabolic waste, these amyloid and tau proteins that we all hear about as being related to neurovascular disease, and they are transported from the interstitial space out of the brain via the lymphatic system. So what I really want to kind of drive home in this topic here tonight is that the health of the brain is about barriers and corridors. And the blood-brain barrier is a crucial immunological feature of the central nervous system. And what it does, it acts like a roadblock for bacteria and fungus and viruses that are circulating in the blood. And if this barrier is breached, then we can actually have autoimmunity against brain tissue. And I just want to mention on the glia lymphatics that you can watch a YouTube video on that and see the actual pulsation of the arteries in the brain and see how that system is moving. So this slide is the blood-brain barrier. And you can see here this junction here. Oh, I'm sorry. Sorry, I'm gonna go back. This tight junction here in the brain looks very much like the tight junction in the gut. And when this tight junction is breached, then we have what's called a leaky blood-brain barrier. And there weren't even microscopes powerful enough to see this until the 1960s. So once this is damaged, then we can have weakened immune cells cross into the brain, and they can attack things like myelin. And this is what leads to nerve damage and the progression to multiple sclerosis. So here we have the blood, the leaky gut now. So here we're looking at the intestines, and we're looking at these villi with these tight junction. And now we're looking at a tight junction that has been breached. And you can see bacteria and viruses and all kinds of toxins and undigested food go back into circulation. And why this is really important is because there is a vagal nerve which connects the gut to the brain, and we can have these bacteria and viruses and pathogens going via the vagal nerve up to the brain. And we can have, if the brain is breached, then we have these particles actually entering the brain and creating inflammation, possible autoimmunity, neuroinflammation. And then we also have a systemic communication link between bacteria from the microbiome. We have the HPA axis, the hypopituitary adrenal axis. We have neurotransmitters. So all of this communication is going on. It's a bidirectional communication via the vagus nerve. And it is so important because we know that certain bacteria in the microbiome, these billions and trillions of bacteria, can affect mood and depression. They can affect the stress response. The military is throwing tremendous amounts of millions of dollars looking at the relationship of the microbiome and Parkinson's disease now, because they know that certain bacteria are coming out of the appendix into the gut and transferring up the vagal nerve to the brain. And there is some type of link with Parkinson's with this, as is environmental toxicities. There are mice that are bred to be sterile. They're called the agouti mice out of Duke University. And they create this situation where some mice are kind of given the Ritz-Carlton environment, and other mice are raised in a very stressful environment. And they look at the microbiome, and then they extract their microbiome, make them sterile, and switch it out. And so the mice that grew up in the Ritz-Carlton environment now have microbiome from the other environment. And what happens is the relaxed mice get stressed out, and the stressed out mice get relaxed. So this probably will be the new frontier of looking at mood and depression and all types of mental health issues, looking at this relationship. This is an interesting slide. I have, this is a slide. These are villi from the intestine under the microscope. And this is from a mouse model. And this is looking at 72 hours after a traumatic brain injury. So they took these slides at 2 hours, 72 hours, and 3 days. And what they found was, as soon as there was a trauma in the brain via the vagal nerve and signaling, somehow these chemicals created an environment where it began to have a leaky gut. And I can really attest and speak to this because I had an automobile accident in 2016 and suffered from a concussion and had thyroid issues. My metabolism really slowed down, gut issues as a result of that. So here's another picture of this. This is a bi-directional gut-brain microbiota axis as a potential nexus between traumatic brain injury, inflammation, and disease. And so we can have physical trauma like a traumatic brain injury, but we can also have post-traumatic stress disorders, chronic stress disorders, trauma from abuse, from emotional abuse, physical abuse, social, sexual abuse, affecting this relationship here. And it's no longer a question as to does it exist. There's just hundreds and hundreds of research articles now on this. So what we have in common here is that we have inflammation, infections, toxins, traumatic brain injury, and chronic stress. And the gut and the brain are very similar. They're both react to inflammation. They both have leaky junctions. They both have breach barriers, and they both have a bidirectional corridor. So we know that the brain and gut are called, the gut's called the second brain, and this is why. So I want to talk a little bit about chemicals and metals. I think it's really, in a way, overlooked. I think we all know they're out there, but maybe it's just actually too painful to think about because, you know, it just seems very overwhelming. But I do want to bring up some points about this. So it doesn't really matter whether you're a vegan or an omnivore or a keto or a paleo. We all face this very explosive toxicity, right? We have chemicals, molds, heavy metals. And so we have to really think about our soil, water, and air. And this slide is from 2009. There's a toxins increased 1,000% since 1940. And if you look to the right, you see these toxins affecting the nervous system and the endocrine system. And this is the brain. I mean, this is and we know that the digestive system communicates to the brain. So this is affecting the brain. And what they found was, they found that pesticides, specifically glyphosates, are endocrine disruptors in children, and that it alters the normal function of the hormone receptor site. So if we are having glyphosates in all of our foods, and these children are going through puberty, this is going to be the beginning of endocrine disruption. They've also found that progesterone synthesis is inhibited in vitro with glyphosates. So think about all the estrogen dominance we're seeing in the PCOS and the infertility. I mean, this speaks to a possible estrogen progesterone imbalance, which is far greater than just putting, you know, pesticides on a plant. The implication can carry generation to generation. And many people think that the glyphosates are put on at the beginning of growing season to kill the weeds. Yes, that's true, but they're also sprayed on the plant to help it dry faster and to be able to go to the mill easier. And then they're now being sprayed a third time on the plant to make the plant die faster and have the capacity to have another growing season. So we're actually getting 3 sprays of glyphosates. There is so much information on them. This is just looking at the average use of crops between 2004 and 2013. And soybeans are 100%, corn at 65, wheat at 25, almonds at 25. So you can get this information from the USDA slides. This is actually 2015. You can go to Environmental Working Group and get the slide. I'm sorry, I have trigger happy year. Here's a sampling of glyphosates found in foods, parts per billion. So we have black beans at 3,000, hummus, oatmeal, Cheerios. If you go to the Environmental Working Group, you can pull up glyphosates in children's cereal, and you'll be shocked to see the top offenders there. General Mills and Quakers being very, very high on the list. And some of the cereals, they found more glyphosates than they did vitamin A and vitamin D put together. And Environmental Working Group did a study commissioning 5 laboratories to look at umbilical cord blood and in a diverse population, and they found over 200 chemicals in each newborn. So if we have exposure to chemicals early on, even before the nervous system is fully developed, if we have trauma in which we develop a leaky gut, and then we have the propensity of pathogens and infections going up the vagal nerve to the brain, we have the potential for developing a leaky brain very early in our life. So here are heavy metals, and heavy metals are known to be neurotoxins. And I thought this was really important point that they can cross the blood-brain barrier. So if the blood-brain barrier is breached, we can have heavy metals crossing. And I see a lot of people in the dental field, being exposed to heavy metals, especially mercury, because of the drilling of amalgam fillings. When they come out, the mercury fibers are vaporizing. And a wonderful website, the International Academy of Oral Medicine and Toxicology, has a wealth of information about heavy metals and its effect. So the kind of big perpetrators in the potential for crossing the blood-brain barrier is mercury, aluminum, lead, and cadmium. I once had a patient who had very, very high cadmium, and we couldn't figure out why, and it came that she was eating on her grandmother's china from the early 1900s that had pigments on them, and the pigments in the paint with cadmium and lead, and when they were heated up, they were getting into the food. So be careful what type of ceramics you're using and plates, etc. Because the half-life of mercury is 20 years, and it concentrates in the amygdala in the hippocampus of the brain. And I bring that up because we know that COVID actually enters through the nasal cavity up the olfactory bulb, and the olfactory bulb connects with the hippocampus in the brain. So it is potentially possible that people that have COVID long haul symptoms may already have toxic overloads or breached barriers. And these are people that might have marcons or mycotoxins or heavy metals already breached. And so they have another insult, which is COVID. And this is why they're having such particularly difficult neurological symptoms to figure out, like the loss of smell and taste and various other ones. This slide talks about how glyphosates are ingested, they go into the gut. But I thought this was also really interesting because they can enter via the optic nerve and smell directly to the brain. So again, we have this olfactory bulb here in this entry to the brain. And This makes us think about the importance of having clear sinuses and air quality and good air filters. I know those of us on this talk here who lived in California have suffered repetitively 3 or 4 years in a row with very, very bad air quality, and a lot of sinus congestion and brain fog, etc. So in our office here, I have an illegal scan, which is spectrophotometry, and it measures 21 minerals, 7 vitamins, and 15 heavy metals in real time. So it's looking at intracellular tissue burden. This is very different than running a blood test, because a blood test is just looking at acute exposure, what's in the blood just right then and there. And the urine tests are looking at what is being excreted. But if we are not a good excreter, meaning we don't have a good dynamic liver and kidney and gut working, and we don't have genetic SNPs that alter that, then we're not going to excrete. And so the results will be skewed and they'll look better than they really are. So I think that all adults should actually consider getting some type of testing like this, like an illegal scan, and also consider getting, if you haven't ever gotten, get some type of stool test just as a baseline for yourself, because these stool tests give us so much information. They give us good bacteria, bad bacteria, digestive markers, inflammatory markers, yeast, parasites, bugs, etc. All the good commensal bacteria that should be living there. So I think that we have to think about having these basic markers as a way of monitoring our health and having good health going forward. There's also urine lab tests now for glyphosates, and you can get a non-heavy metal 773 chemical test looking at all the chemicals in the environment. I had a person who had these very, very high chemicals, and it had to do with them traveling and being on highways in Los Angeles with the windows down and the chemical exhaust from gas and tar and rubber from tires coming back up. And they were inhaling this because they were sitting for hours in stuck traffic. Okay, so between now and the third series, when we're going to kind of dig deep into all the things we could do, I thought I would just talk about some really simple steps to begin for brain health. B vitamins have found to be very helpful for repairing the blood-brain barrier, especially B1, 12, and folate. Because the microbiome and the gut are so related, we can increase the diversity of our vegetables and consume more fibers and starches, because these make something called short chain fatty acids, and they lay the groundwork like a fertilizer for the small intestine. So we naturally make more good probiotics. It's a way of getting in probiotics without taking them. And then with a richer, more robust microbiome, we have a healthier gut. We can increase our antioxidants, our polyphenols, our flavonoids, all those orange, deep reds, blues, purple vegetables, trying to be organic. Glutathione is considered by the World Health Organization the most powerful antioxidant there is. It helps regulate both phase 1 and phase 2 liver detoxification. So it's helpful throughout the whole liver for detoxifying chemicals and hormones and heavy metals. And it decreases by half after the age of 50. So those of us who are over 50 have to really think about our longevity and what we can bring on board for our gut and brain, and glutathione really is the ticket here. So stress reduction, I think we've all heard a lot about stress reduction this year, because all of us have just been kind of called to our limits with having to manage stress with the pandemic. So it's, all the usual suspects with sleep and exercise and food and getting off Wi-Fi, et cetera. Wi-Fi especially affecting the brain. We could have a whole 1-hour discussion on that for sure. But increased circulation, via movement, Tai Chi, Qigong. Jean does medical Qigong, which I hope she does a presentation online for everybody. Exercise, helping increase nitric oxide in metabolism, circulation, lymphatic flow, oxygen, ATP. There's a peptide called bone-derived neural growth factor, it's BNDF, and that helps grow new neurons and helps with the synapsing. And this can be made by our bodies with 30 seconds of intense exercise. So 30 seconds of squats or jumping jacks or running in place, right before you open the refrigerator door, right before you turn on the stove, right before you do the laundry, just, 30 seconds of squats to really increase your natural BDNF. So this is actually a redundant slide from the one above as far as increasing antioxidants and polyphenols. So I think that wraps it up for me. I hope that you all gained some insight into the relationship of the gut and the brain and how they are a bidirectional corridor, and how what is breached in one barrier may also be breached in another. And we have to think about, as we age, repairing our barriers, because in the gut, we lose our mucosal linings and we lose something called secretory IgA, which is an immunoglobulin in the gut that helps fight infection. And they actually found a correlation with people that had very particularly difficult COVID symptoms having low secretory IgA. So this is where the focus is our gut and brain. And the next recording will be Jean Hilton, and then we'll see you all next Tuesday, the 19th, to have our second session on the brain. Okay, thank you for joining.